Hi students. So in this video we are going to discuss about properties of rational numbers. Properties of rational numbers. So let us see the properties of rational numbers. Properties of rational numbers. Properties of rational numbers is a very important topic. It is very necessary topic and it is also very basics or fundamentals for mathematics. So now in this video, we are going to discuss about properties of rational numbers. We know already very well what is a rational number. A rational number is rational number. Let us see that rational number. Rational number. What is a rational number? Any number can be represented in the form of p by q. Any number can be represented in the form of p by q is known as rational number. That means any number, any number, any number any number can be represented, can be written or represented, can be written in the form of, in the form of, in the form of p by q, where p comma q belongs to integers and q not equals to 0. So this is called rational number. So what are the properties of rational number? The properties of rational numbers, we have basically mainly four properties. So first one is closure property. Closure property. What is a closure property? So this closure property, we are going to verify four arithmetic operations. So what are the arithmetic operations? We know we have four arithmetic operations mainly. First one is addition. Second one is subtraction. Third one is multiplication. Fourth one is division. In our mathematics, there are four arithmetic operations. One is addition, subtraction, multiplication, and division. So now in these four operations, we are going to check whether the rational numbers are closure or not, or closed or not. Let us see first. Closure property over addition. So closure property of rational numbers. Let me take any two rational numbers. If you take any two rational numbers, if you add any two rational numbers, let a comma b are any two rational numbers, or any two rationals. Let a comma b are any two rationals. If a plus b is also rational, then it is closed over addition. That means, what it means, that if any two rational numbers we are going to consider, if you add those two rational numbers, the sum should be rational, then it is known as closure property. So let me consider first two examples. So you can take 3 by 4, a rational number, plus 1 by 2 is another rational number. Let you add these two, 3 by 4 plus 1 by 2. So once you have to remember that we should not add directly, because these two are not like fractions. So if you add fractions, so it must be like fractions, otherwise we should take the LCM for this. So what is the LCM? 4 and 2 LCM is 4. So 4 1 times, so 1 into 3 plus, here 2 will be 2, in 4 2 times will come, so that is 2 into 1 2, that is remaining, this is 5 by 4. So here 5 by 4, 5 is P and the 4 is Q. Numerator and denominator both are integers and Q is not equal to 0. This 4 is not equal to 0 and 4 comma 5 or belongs to Z, then it is a rational number. If you add any two rational numbers, the sum of those two rational numbers will be again rational, then it is closure property. So this is called closure property. Then coming to closure property over subtraction. So coming to closure property over subtraction, if you add any two rational numbers or if you subtract any two rational numbers, so then in this place you should take minus. So then also be rational, it is closed over subtraction. So it is closed over subtraction. Then so if you add, subtract these two. So 3 by 4 minus 2, this is, so take minus 3 minus 2 by 4. So it becomes 1. So it becomes 1 by 4. Yes, it is also closure property over subtraction. So once you check what is the closure property over subtraction, a comma b are any two rationals. If a minus b is also a rational, then it is closed over subtraction. Then under this rational numbers, closure property satisfies subtraction also. Then coming to the multiplication. So what about multiplication? Let a comma b are any two rationals, then a into b, the product also be rational, then it is closed over multiplication. This is closed over multiplication. Now we are going to write here multiplication symbol, then it becomes multiplication. So not like this. Multiplication is directly we can do. So multiplication directly we can do. So both numerators multiplication 3 into 1 3. Both denominators multiplication 4 into 2 is 8. Then this is called 3 by 8. Now it is also 4 multiplication. This is also a rational number. Then according to this, if you consider any two rational numbers, then the product is also a rational. Then we are calling it as closure property over multiplication. So coming to the division. So what is the closure property over division? You can see now. So closure property over division. So you can see. So it is divided by, or you can take divided by a by b. A by b is also a rational. Then it is closed. So here it is not rational. Let me consider first. So you can take it is 1 by 4 divided by 0. So 1 by 4 divided by 0. So if you take any calculator, so if you divide any rational number with 0, then we can get math error. That means we cannot multiply, we cannot divide this one, we cannot divide this one. So 1 by 4 divided by 0. So divided by 0 means what? Divided by 0 in the sense, so it is not that is not calculated. This is, so we cannot process this one, we cannot process. So that means there is no value here, there is no value, so we cannot process this one. So that is not there in mathematics. So that's why it is not possible. This is not possible. This is not possible. So whenever it is not possible, then so division is not possible, not closed over rational numbers. Division is not closed under rational numbers. That means, so this is about the closure property. Have idea about the closure property. Now we are going for another property. Is known as commutative property. What is commutative property? What is commutative property? So commutative property, we can see commutative property. Let me consider again. So a comma b are any two rational numbers. A comma b. Let a comma b are any two rationals, or any two rationals, then a plus b is equals to b plus a. If you add a plus b value, then again if you add b plus a value, if the both gives the same result, then it is suitable for commutative property. It is commutative property. Then a plus b is equals to b plus a is known as is known as commutative property. Commutative property. Let A comma B are any two rationals, then A plus B is equals to B plus A is known as commutative property. So here also under commutative property there are four arithmetic operations: addition, subtraction, multiplication, division. The four arithmetic operations. So now we can check that is do we take any two rational numbers? Let A, in the place of A we can take, again I am taking, that is 1 by 4 plus 1 by 2. What it happens? 1 by 4 plus 1 by 2. If you take two numbers, then what is their addition? Addition is 4 and 2. So LCM we should consider, this is 4. Next 4 ones 1, that is 2 times it becomes 2, that is 3 by 4. 3 by 4. Then whereas 1 by 2 plus 1 by 4. So first we consider A plus B, next we need to consider B plus A. Next 2 and 4, same, again 4 is the LCM, this is 2 times, that is 2 plus, even only one time, that is 1, this is also 3 by 4. Both will use the same result. Whenever if you add A plus B or by reversing the numbers B plus A, so we may get same answer in the commutative property. If you get same answer, then it is suitable for commutative property, otherwise it is not suitable for commutative property. So what it is concluded that here is addition is suitable under commutative property for rational numbers. Okay, let me consider now subtraction, what it happens now. So subtraction, let me check, this is subtraction. The same statement, but in the case of here we should take minus because of it is subtraction. So 1 by 4 plus 1 by 2. So if you subtract 1 by 4 minus 1 by 2, so what happens? This is minus. So this is 1 minus 2. Is it possible? Yes, it is possible, 1 minus 2. But here the magnitude has a negative symbol, so greater magnitude has negative symbol. That's the reason why we should get negative here. So negative here. Okay, that is 1 by 4. 1 by 4. Now coming to here is again minus, then it is also minus, then 2 minus 1. So that is 1 by 4. 1 by 4. 1 by 4. So what it means that here, let me check, this is minus 1 by 4 and this is 1 by 4. So minus 1 by 4 is differ from 1 by 4. So that's the reason why subtraction is not suitable for commutative property. Subtraction is not suitable for commutative property. Only addition is possible here. So now we are going to check commutative property over multiplication. So under multiplication you can check this is, so same statement. If you multiply A into B and if you multiply B into A, so if A into B is equals to B into A, then it is suitable for multiplication, otherwise it is also not suitable. Let me check whether it is suitable or not. So by taking same example, that is 1 by 4 into 1 by 2. So if you multiply 1 by 4 into 1 by 2, what happens? 1 into 1, 1, 4 2s are 8. Now coming to 1 by 2 into 1 by 4, that is again same, 1 into 1 and 2 into 4, we get same result. That's the reason why multiplication is suitable. Next, coming to the division. So let me take division. So for division, so you can take this is, so A divided by B and B divided by A. Let me check whether it is suitable or not. So 1 by 4 divided by 1 by 2. So how to solve this one? So we know that how to do the divisions. So for the rational numbers or fractions. Let me check. This is 1 by 4. So division becomes multiplication. Then this number will become reciprocal. That is 2 by 1. So now you can say this is 2 ones are 2 and 4 ones are 4. So this simplification is possible. 2 ones and 2 twos we get same. That is 1 by 2. 1 by 2. Now coming to B by A value. This is 1 by 2 divided by 1 by 4. So let me check. This is again 1 by 2. So in the place of division we can take multiplication, because after the division symbol the fraction becomes reciprocal, that is 4 by 1, that is 4 by 2. So it is 2 ones, 2 2s get cancelled. So here 1 by 2 is not equals to 2. That's the reason why division is not suitable for commutative property. So what is the commutative property now? What we understand from the commutative property? So commutative property is nothing but, if we are going to do the one operation, either addition, subtraction, multiplication, division between any two numbers, if you interchange the numbers by the same operations, if you get same answer, then it is suitable. If it is not get same answer, then it is not suitable. So here under the commutative property, addition and multiplication is suitable, subtraction, division is not suitable. So I hope you understand. So now we go for another property, that is called associative property. So what is associative property? Let me check now. So very simple, associative property. Associative property. What is associative property? So to check whether it associative property, we should consider three rational numbers. So three rational numbers, let A, B and C are any three rational numbers. Any three rational numbers. Like A, B, C are any three rational numbers, then A plus B plus C is equals to A plus B plus C. So associative means, if you add first two numbers, then you add that sum, then you add a third number to that sum, will remain the same as if you add last two numbers and the first number is added to their sum, then the total value should be same, the remaining remains constant. So if you get like this is associative property, otherwise it is not associative property, not suitable. Let me check here also 4 arithmetic operations. So this is addition, subtraction, multiplication and division. So for 4 arithmetic operations we are going to check first. Let me take the same example. We can take this is 1 by 2 plus or 3 by 2 plus 5 by 2. So for our better understanding, so we can take same denominators. So if you add these values, what happens? 1 by 2 plus 3 by 2. First we are going to add inside the bracket value, according to BODMAS rule. Okay, so that is 1 by 2 plus 3 by 2. How much it becomes? 1 by 2, 3 by 2. Both are like fractions. That's why directly we can add, that is 4 by 2 plus 5 by 2. So what it happens? 4 by 2 plus 5 by 2. This is 9 by 2. So we are getting 9 by 2 answer. Now, so we are going to consider RHS side. So this is LHS side. LHS you consider. Then RHS. So you can consider RHS. What happens? 1 by 2 plus, this is 3 by 2 plus 5 by 2. So what happens now? So first we are going to add inside the bracket value. So what is? So 2, same denominator. That's the reason why we can add directly. This is 8 by 2. So 8 by 2 plus 1 by 2. Again it is 9 by 2. Yes, it is suitable for addition. Associative property is suitable for addition. Then now coming to whether we have to check whether it is subtraction possible or not. Let me check. Subtraction in the sense, so we are simply changing the symbol sign. So that is minus. What it becomes now? Let me check. If you take minus value and minus, this is also minus, this is also minus. So is it possible? Let me check. So if you take this is minus and this is minus and this is minus and this is minus. Now we can subtract first inside the bracket value. This is 1 by 2 minus 3 by 2. What happens? 1 by 2 minus 3 by 2 becomes minus 2 by 2. This is minus 5 by 2. What happens? This is minus 7 by 2. Both are having negative symbols. That's the reason why we should add the numbers. That is minus 7 by 2. Then coming to here, this is 1 by 2 minus. So what it happens? This is again, this is minus 2 by 2. 3 by 2 minus 5 by 2. So same value, 3 minus 5, that is minus 2, same. So now if you take this value, this is 1 by 2, minus into minus becomes plus, this is 2 by 2. So total value becomes 3 by 2. So here this is minus 7 by 2 and this is 3 by 2. But this is not, both are same. So when the result is does not same, so hence that's the reason why this is not suitable. Subtraction is not possible over associative property. Subtraction is not possible over associative property. So associative property means that simply we are going to perform first two numbers operation, then the another number is added or subtracted or multiplied or divided by with that value. So again we are changing the brackets, that's it. So by changing the brackets we can get the associative property. So next, so under the multiplication, let me check whether that is multiplication is possible or not. So for same values you can check multiplication possible or not. Let me check. So it is very easy how to solve this values, whether it is suitable or not. So we are going to use the multiplication symbol. So multiplication is LHS and RHS values. Let me check now. So 1 by 2 into 3 by 2. That means what? 1 into 3, 3, 2 into 2, 4. That is 3 by 4. Into, this is 5 by 2. What it happens? 3 5s are 15 by 8. This is the value of LHS. Then coming to RHS, how much? This is 1 by 2. 3 by 2, 3 into 5, 15. This is 2 into 2, 4. Then what happens? 1 into 15, 15. 2 4s are 8. Yes, same result will come. So what it means that multiplication is suitable. Multiplication is possible over associative property. Then coming to division, let me check last division. So once you check the division, so we are going to use the division symbols. So divided by, divided by, divided by, divided by. So you can take divided by here, you can take divided by here, you can take divided by here, you can take divided by here. So let me check. 1 by 2 divided by 3 by 2. First we have to take bracket. This is 1 by 2. Divided by, in the sense, we can take multiplication. This becomes 2 by 3. Into, this is also can be reversed. This is 2 by 5. So what is the value now? 2 1s are 2. 2 get cancelled. This is 1 by 3 into 2 by 5. This is 2 by 15. So now what is the answer now? This is 1 by 2 divided by, first bracket inside. This is 3 by 2 into 2 by 5. 2 get cancelled. So now it is 1 by 2 divided by 3 by 5. This is 1 by 2 into 5 by 3. So what is the answer? 5 answer 5? 6. Now it is also, this is 2 by 5 and this is 5 by 6. So it is not suitable. This is division is not suitable. So associative property is not suitable over divisions. So associative property of rational numbers, associative property of rational numbers is suitable for addition and multiplication, but it is not suitable for subtraction and division. So this is a very important topic. So after associative property, we go for distributive property. What is the distributive property? Distributive property, you can see both multiplication and addition at a time. In distributive property, we can check both multiplication and addition at a time. So coming to the distributive property of multiplication or addition, distributive property. Distributive property of multiplication multiplication over addition. So let me check distributive property over multiplication or addition. Let me check. Here it is. Let A, B and C are any three rational numbers. So rational numbers are any three rational numbers. So what it is that A into B plus C is equals to A into B plus A into C. Let me check like this. This is distributive property. So A into, if A is multiplied both B plus C, then it is distributed to, A is distributed to B and A is distributed to C. Now A into B plus A into C. Whether this result we have to verify whether this result is possible or not. Then it is suitable. Let me check A. A is 1 by 2 into, so B is 3 by 4 plus 1 by 4. Let me check like this. So what is the value this one? 1 by 2. 1 by 2 into, both are like fraction, that is 4. 3 plus 1, 4 again. 4 by 4. So 4 by 4 means 1. That is answer is 1 by 2. 1 by 2. Then coming to this side, A into B. So A into B means 1 by 2 into 3 by 4 plus, this is 1 by 2 into 1 by 4. So what happens? This is 1 by 2. So 1 into 3, 3 by 4 2s are 8 plus, this is 1 into 1, 1, 4 2s are 8. Then coming to this side, so 8 is LCM because same denominator, 3 plus 1, 4. 4 1s, 4 2s. So you get 1 by 2. Same answer will come. Then it is, this is called distributive property over distributive property of multiplication over addition. So these are the properties now. So we are going to check what is the multiplicative inverse. What is the multiplicative inverse? Another important topic. What is multiplicative inverse? What is the multiplicative inverse? If you multiply any two numbers, or if two numbers are involved in the operation of product, so multiplicative inverse. What is multiplicative inverse? Let me check. So if you multiply, if A into B is equals to 1, the product becomes 1. If you multiply any two numbers, the result, the product is equals to 1, then the two numbers which are involved in the multiplication are known as multiplicative inverse to each other. Then here from this side, this can be written as, here B can be written as 1 by A. So what is the multiplicative inverse of A? The multiplicative inverse of A is multiplicative inverse of A is 1 by A. Of A is 1 by A. Now another way, if you multiply any two numbers, if you get multiplicative identity, then those two numbers, so we are calling it as multiplier and multiplicand. Those multiplier and multiplicand are called as multiplicative inverse or reciprocals to each other, or they are calling it as reciprocals. A comma A, 1 by A, or reciprocals. A comma 1 by A reciprocals. So simply we can take 2. What is the reciprocal? 1 by 2. So 3. What is the reciprocal? 1 by 3. Okay. So 5 by 7. What is the reciprocal? 7 by 5. just we can interchange the numerator and denominator, we may get the reciprocal. But here one most important point is there. So a number having its own reciprocal, that is 1. 1 into 1, we get 1. So any number, it has own reciprocal. So that means that number is 1. And minus 1 also. Minus 1 into minus 1 also 1. So minus 1 and plus 1 are special values which are having same reciprocals. Same number as reciprocals. That is 1 and minus 1 both are same number of reciprocals. Very, very important concept. Now in this concept we discussed multiplicative identity and multiplicative inverse also. Then coming to additive inverse. So what is additive inverse? So let me check what is additive inverse. Additive inverse. Additive inverse. If you add any two numbers, the sum will becomes additive identity. So if you add any two numbers, that is a plus b, so the sum will becomes additive identity. Then it is known as additive inverse to each other. Then those two numbers addends. These two addends are known as additive inverse to each other. Here b becomes minus a. Here b becomes minus a. That means if a is any number, what is its additive inverse? Minus a. Simply by changing the sign. So if minus a is one number, what is its additive inverse? Plus a. Plus a. If minus 3 is one number, this is plus 3. So it is very simple. By changing the symbol, so we are calling simply it is a negative of a number. Negative of a number. So negative of a number. Additive inverse is nothing but negative of a number. So if you take a, so what? If you take 7, so what is its negative of a number? Minus 7. If you take minus 5 by 3, what is its negative of a number? Plus 5 by 3. This is negative of a number. So that if you add these two numbers, we get additive identity, that is 0. Additive identity, it is 0. So students, I hope you understand very well about the properties of rational numbers. Today's class is very important. In next classes, so we can do for more basics. So thank you.